Alright, today we're going to be testing the myth that you can start your car with one lemon. There was a myth that a man was able to restart his car with the power from one lemon. So today we're going to be testing a lemon, an orange, and a potato. Let's see what happens. Alright, so my prediction for this is I think lemon will produce the most voltage, and then orange, and then potato last. And I think it would take 50 lemons to produce enough voltage to power a car. I'm gonna say 30 oranges, 70 oranges, and then probably 100 potatoes.
So I think lemon is gonna produce the most voltage, followed by orange and potato, because in order for a fruit to produce electricity or work as a battery, there must be an acidic medium. So lemon and oranges, they contain citric acid, versus with potato, I'm not sure whether it's acidic. So that's why I'm into a conclusion that lemon or orange would produce the highest amount of voltage.
And how many of each fruit do you think will take to power a car or a truck?
Probably like 10 lemons or an orange would be enough to power a truck.
Okay. Okay, so I think the lemon will have the most voltage, then orange, and then potato as well. For as into how many it will take, I think it probably take around 20 to 25 lemons to produce enough voltage to power a car. A truck, probably like, let's say 50. Let's put it there. For the other two, I don't know.
Here's how we set up the fruit for the experiment. As you can see, we have our zinc nail and our copper penny. And forgot to make an incision, so bit of a struggle with the penny there.
For a battery to work, we need two different metals and an acidic medium. So that's why we're using zinc, the galvanized nail that contains zinc, and the copper penny, which contains copper. And another reason why we chose either lemon or orange or tomato is because they contain some sort of acid, and in order for a battery to work, we must need an acidic medium.
Alright, so this is trial number 1. We have our lemon here, the zinc nail on one side, the copper penny on the other. Let's plug it in. Alright, as you can see, we have a little movement there, not much.
Would you say it's a success or failure?
I'd say it's a minor success. We got a little power, but we'll see what happens with the other ones. Alright, so this is our second trial. This time we have an orange, and again, the nail on one side, the penny on the other. Alright, very little movement there. A tiny bit maybe, but not much. Alright, this is trial number 3. This time we have a potato. Nail one side, copper on the other. Alright, as you can see, a little movement there. Maybe the best we've had so far. Not bad.
So in our experiment, we had a galvanized nail that contains zinc and a copper penny which contains copper. So zinc acts as an anode where the oxidation takes place, as a result of which zinc metal is converted into zinc ion. And in the cathode, the 2 electrons lost by zinc is accepted by copper, which accounts to the electric current.
Alright, this is trial number 4, and we're retesting the lemon. Let's see how it goes.
A smaller lemon a bit.
Not much movement.
Failure?
Possibly.
Failure, Professor?
Failure is just knowing how to do it better next time.
Yes, sir.
There you go.
Alright, this is trial number 5. This time we're doing our second try at an orange. Alright, as you can see, we're getting some good reading there. Probably our best trial yet. Alright, this is trial number 6. This time we're gonna join 2 lemons in a parallel fashion. So first we'll hook up our original setup like this. then we'll connect right here. Finally, connect our copper here. Alright, as you can see, we're getting a little reading there. Not too bad.
Not too different from the
Minor
single
success. Yep. Alright, this is trial number 7. This time we got 2 oranges that we're going to connect in a parallel fashion again. So our original setup here. Alright, small reading there. Surprisingly not as good as 1 orange, so very interesting. Alright, this is trial number 8. This time we're going to try 1 orange with 1 lemon. Again, connecting it in a parallel fashion. Alright, small reading there. Interesting result. Worked a little bit. Alright, this is trial number 9, and this time we hooked up 2 potatoes in a parallel fashion, and we got a little reading. Not bad.
There are 2 ways of connecting multiple batteries in a circuit. One's called the series combination and the other one's called the parallel combination. So in series, let's say if we have 2 batteries of a volt, then the total voltage of that circuit would be 1 plus 1 versus in parallel. Versus in parallel, let's say if we have 2 batteries measuring 1 volt, then the total voltage of that circuit would equal 1. So since we need more voltage to power the truck, that's why connecting the circuit in series would be a good idea.
Alright, this is trial 10. This time we connected 2 lemons in a series fashion. As you can see, not much reading, which is similar to the parallel from lemon, so not surprising. Alright, this is trial 11. This time we have 2 oranges connected in a series fashion, and not much reading, which is a contrast to the parallel fashion for oranges, so very interesting. Alright, this is trial number 12. We have 2 potatoes connected in a series fashion, and there's a little movement when we plugged it in, but not much at all, so yeah. Alright, so this myth is busted. We did get some voltage for each of the different fruits that we tried, and for the orange, lemon, and potato, we got some voltage when we connected it up with just 1 and with 2 in both series and parallel. The parallel did actually work better, which was surprising. And yeah, so this myth is busted. It would take a lot of each type of fruit and vegetable to power a car. So yeah, this myth is definitely false.